Hello and welcome to my podcast about spectral class. Today we're going to look at Hertzsprung-Russell diagrams and a table showing spectral class. Here is the Hertzsprung-Russell diagram. This diagram has three main parts: the main sequence, the giants, and the white dwarfs. You can tell from this diagram that the higher the surface temperature of the star, the greater its luminosity. The colour of the plot on the diagram is a good indication of the colour of the star itself. We know by observation that the colour of the Sun is yellow, and on this diagram its luminosity is equal to 1. Therefore, this must mean it's a G-class star, and as we know that it's 5,800 degrees Kelvin on the surface of the Sun, we can determine that it is a class G2 star. This table shows spectral class. Each star is given a letter dependent on which class it is in, which is dependent on the temperature of the star and therefore the colour. Hot stars, which have temperatures above 20,000 degrees Kelvin, are O-class stars. Such a high temperature means that the particles inside the star have a very high energy. This allows helium to be ionized, which we can see as main absorption lines in the spectra of the star. As we know the Sun is a G-class star, we now know from this table that it's yellow-white in colour, and the main lines of its absorption spectra is an abundance of calcium ions. As spectral class is not in alphabetical order, it can be hard to memorize. You can use techniques like mnemonics to memorize them. Some astronomers use "Oh be a fine girl, kiss me". However, you can always spell out a Bafgacum, or, as one of my favourite mnemonics, "Oh bugger a fucking giant killer moth". I hope you enjoyed my podcast. Thank you for watching. Good